All right, I am going to be using my notes to complete problem number 1. In the exponential growth model, y equals a times 1 plus r raised to the t power. The quantity 1 plus r is called the growth factor. The variable t represents the time period. The variable a represents the initial amount. The variable r represents the growth rate. So, in problem number 2, the owner of a 1953 Hudson Hornet convertible sold the car at an auction. The owner bought it in 1984 when it was valued at $11,000. The value of the car increased at a rate of 6.9% per year. I need to write a function, so I need to have each variable. The initial amount was $11,000. That's how much it was worth in the beginning. The growth rate is 6.9%, but we need it as a decimal. So that is 0.069. Remember, to change a percent to a decimal, you move the decimal 2 spots to the left. The growth factor, 1 plus r, equals 1.069. And t was not given to us, so it's just going to remain the same. Now I use my growth model up here, and I substitute my known variables. So y equals 11,000 times the quantity 1.069 raised to the t power. That is my function. So, the auction took place in 2004. What was the approximate value of the car at the time of the auction? Round your answer to the nearest value. All right, 2004. I need to figure out what t equals. So I need to figure out 2004 minus 1984. How many years have gone by? 20 years. So t equals 20. Now I substitute 20 for my exponent in my exponential growth model function. So I'm substituting t is 20. I'll put this in my calculator. 11,000 times the quantity 1.069 raised to the 20th power. And that car now has a value of $41,777.92. That car is worth a lot more money in 2004.